Hi guys, welcome to Press Shift Return puzzle number 2, Rat and the Poison. This is a very interesting question and checks your fluency in playing with the number system and being able to identify a problem and convert it into a binary number system from a decimal number system problem. So let's come to the question. The question is that there are 1000 wine bottles. As you can see here, we have many bottles here, and one of these bottles contains poison. So this one bottle here, right here, contains poison, and there are rats available in the lab, and there are wine bottles available in the lab. Wines are being tested, and rats are drinking the wine. Now, what's happening? Okay, I know you're thinking lucky rats, but one of this is poison. So let's think again. What's really happening is that a rat dies after 1 hour of drinking the poisoned wine. Okay, so that's the problem. And the question is, how many rats are needed to figure out which bottle contains poison in 1 hour? So you have just 1 hour, and obviously there are 1000 wine bottles, and you can have 1000 rats for each 1000 bottle, right? And then you can just see make each one drink each wine, and only one rat dies, and you know which wine it was. But say you want to do it in using lesser number of rats, you don't have that kind of supply of rats, so how would you reduce the problem? Okay, now when you're trying to reduce this problem, minimum, how many minimum rats are needed, and you know the total number of rats needed in this problem as it is 1000 rats, right? So let's just think about it a little bit more. So what is happening when you have these 1000 rats? What is actually happening is that you have these bottles, and you can number them, each of these bottles, but what you really want to number is your rats sitting in and drinking this wine. Okay, so for each rat that is drinking this wine, you can number these rats also. You can number these rats as 0, 1, 2, 3, 4, or say rat 1, rat 2, rat 3, rat 4, and so on. Okay, now what? So how do you solve this problem? Because if we go by this scenario, there will be 1000 rats needed, and every single rat would go to every single wine and drink it. So you will have 1000 rats, and say the 576th bottle contains poison, so the 576th rat would die, and hence you will know which bottle contains poison after 1 hour, right? Simple. But we can make it simpler. We can reduce the number of rats just by converting this problem from decimal to binary. How would we do that? So we have 1 to 1000 numbers. We are using 1000 different numbers to identify these rats, right? We have 1 rat, rat 2, rat 3, so we have 1000 rats and 1000 bottles. The bottle will remain constant, but the number of rats can reduce. So if I move from a decimal to say a binary problem, what would really happen is that my problem would reduce from 1000 wines will remain 1000 wines, but 1000 bottles will 1000 rats will become how many? What does that mean? That means that I need at least 10 binary bits, 0 and 1, to display a combination of 1000 numbers at least. So if I have to write 1000 numbers, how do I represent 1000 numbers in binary? How many bits I'll need? I'll need only 10 bits. I'll not need 1000 numbers, individual numbers like in decimal system. I only need 10. So you always remember this thing. So just like in decimal form you have 8 numbers, but you only have 3 bits. You only need 3 individual bits to represent these 8 numbers using 0 and 1, right? So your problem can be solved just the same way. In this scenario you need only 10 bits to define all these 1000 rats, right? So what is happening here is that this rat 1, rat 2, rat 3, rat 1000 are now represented with just 10 numbers, which are binary numbers. So we have 0 0 0 0 0 0, right? That's it. So and similarly like this, and all the numbers in between. Only 10 bits needed. Now what will you do? You will assign each bit to one rat. Okay, so rat 1, rat 2, rat 3, rat 4, and so on. And what will 0 and 1 represent here? 0 and 1 is representing whether the rat actually drank from the bottle or not drank from the bottle. So you can say, actually you can say 1 means drank from the bottle, and this means he did not drink from the bottle. Okay, so that's what it means. So now I'm going to write some I'll just take one random number from this entire thing, which is 0 0 0 0 1 0 1 0 1 0. What does this mean? This would mean that if I start from this bit, so this is say rat 1, I can start from rat 1 here, or I can start from, let's say we start from the least significant bit, and this is rat 1. So we know rat 1 didn't drink this wine, okay, and we have 1000 different wines being represented in this way, and we know that rat 2, 3, 4, 5, 6. So rat 2, 4, and 6 drank from this. Okay, that's it. That's all you need to do. Or if you want to go from here, I think least significant bit is this, right? So you would go 1 2 3 4, rat 5, rat 7, rat 9. Anyway, it's good. Okay, so you know that. So you know that rat 2 4 6, right? So for example, you know rat 2 4 6 died, so you know rat 2 4 6 died, but there is only one combination in which rat 2 4 and 6 drank this drink or wine, right? And which wine it was, you can find that out by just converting this binary into decimal. Okay, so going from 2 raised to power 1 plus 2 raised to power 3 plus 2 raised to power 5, it's 32, plus 8 plus 2 is 42, right? So that's how you come to this conclusion, that wine number 42 contains the poison, and you needed only 10 different rats to find out that which bottle contained poison. right? So that's how we get to the answer 10. Okay, thank you very much.